9-6. So 9-6 is all about modeling with trig functions, and we are going to be focusing specifically on word problems. So the first thing you guys have to know is that with frequency, it is typically, because of our sine and cosine and their properties, they sort of have this oscillating motion. So oscillating motion is just basically just going back and forth over and over. And because we have a couple of things in real life, such as radio waves, or maybe we have like a circular object we would like to graph that follows just like our unit circle that follows an oscillating motion, so we can use sine or cosine to represent that. So there's a lot of different applications that we can use, and so that's what this section is about. We're going to apply it to some examples. So one of the things you have to know is frequency. Frequency is one of the most important things from this section, because typically sine and cosine is going to be used for our sound waves. Sound waves is probably the most common way you're going to see it. If you take like a physics class and you want to figure out, at what time is this particular sound wave going to reach your ear, you can actually calculate that. And so one of the important words for the sound waves is frequency. Frequency is just the reciprocal of the period, okay? It's just the reciprocal of the period. And it is, instead of giving your information in, I guess you could say, distance, such as a radian, which is what we've been doing, we are now going to portray it as the number of cycles per unit of time. So usually this will be like number of cycles per second or half second or whatever it may be. And so I went ahead and I drew, or I didn't draw, but I included just some information for you here at the bottom, just to show you that these waves are very applicable. If we had no knowledge, we would not have certain things, like we wouldn't have the radio, or we wouldn't have our cell phones. Cell phones are like right around here. Cell phones. So if we didn't understand our frequency, if we didn't understand oscillating motion, if we didn't have a way to calculate it and to predict it and to model it with sine and cosine, we wouldn't have cell phones. Okay. Of course, as you increase your frequency, as you increase your wavelength, if you will, then we start getting into some more hazardous stuff. And then ultraviolet, that's just what we see. So some of these wavelengths we can see. In some of your science classes, you may have already discussed how certain objects are different colors and how they're not really that color, but merely reflecting that color's wavelength. You might have seen videos online about the different wavelengths and how they are affected on the surface. And then as you go below, as you go under the sea, if you will, if you scuba dive, then those wavelengths begin to dampen. And so you can look up cool videos like that to sort of give you an idea. But let's go ahead and do a quick example of using frequency. This problem says a sound consisting of a single frequency is called a pure tone. An odometer produces pure tones to test a person's auditory function. So this would be typically, if you're like looking at this and be like, that's a stupid invention. Actually, people sometimes use this to test hearing on babies, especially if they're deaf or anything. They would use an odometer, so don't diss it. An odometer produces a pure tone with a frequency of 2,000 hertz, which is just cycles per second. It's the standard unit for sound and wavelengths. And then the maximum pressure P produced from the pure tone is 2 millipascals or pascals. Write and graph a sine model that gives the pressure P as a function of the time T in seconds. All right, so the first thing we can do is we can sort of draw. We can say P is going to equal A sine of bx. Okay, so A being our amplitude, sine because they told us to use sine, and then B is where we get our period from. So the first thing I can do after reading this question is I can see that at the very last sentence it says write and graph a sine model. And so my basic sine model is that P equals A times sine of bx. And I know it's going to be this particular format just because I know that I have my amplitude that I have to deal with, and I have a period because every single sine and cosine function has a period, and particularly it has a period of 2 pi. So I can just easily see, I know it's going to be sine instead of cosine. The next thing is that I know that the period previously is 2 pi over b, as I said before. And so the other piece that I have is that frequency. The frequency is the reciprocal of that. So frequency would be b over 2 pi. And then they tell me what my frequency is. They tell me that my frequency is 2,000 hertz. So I'm going to plug that in for the frequency, not for b. I don't know what b is yet, but that's what I'm going to solve for in a second. So I'm going to plug in 2,000 for my frequency equals to b over 2 pi, and I'll multiply 2 pi on both sides. It'll cancel out on the right, and this will end up being, and remember when you're doing this, just keep pi at the very end. So I would really only be multiplying 2 and 2,000. So 2 times 2,000 is 4,000, so therefore b equals 4,000 pi. All right, so I have my b value. Now I need to figure out my a value, and my a value comes from my sentence. My sentence says the maximum pressure produced from my pure tone is 2 millipascals or pascals. So it depends on so this is the only other number that I have. So I'm just going to go ahead and plug that in for my a value. So I can write my equation as p equals 2 times sine, and then I'll plug in my b value, which is 4,000 pi, and then I'll add the x at the very end, and this becomes my equation. If I wanted to graph it, and it's not super important that you graph it, the most important piece from this is to be able to look at and create the equation. But if we were to create a graph, remember it's going to be based on time. So I'm going to say that the x value is going to be p, which is our pressure, because remember this is a function for pressure, okay? It's p as a function of time. So that means our x value is going to be t for time. And I'll add a couple tick marks, and just not really super important. I know a sine function starts at 0, and before I do that, I want to figure out, well, what is my period going to be? So my period, remember, period is going to be 2 pi over b, or it is the reciprocal of frequency, so I can write my period as 1 over frequency, and I know what my frequency is. It's 1 over, I know it's 2,000, so it would be 1 over 2,000. I could figure out what that is as a decimal, but that's too much work. So I'm just going to say that I have sine starting at 0, it goes up, it goes back down to 0, it goes down, and then it goes back up. That is one complete period. So I know that at the end point right here, if I were to draw it, the end point would be 1 over 2,000. And that means the x-intercept, the halfway mark, if you will, would be half of that, which is 1 over 4,000. Okay? So, and that makes sense. Okay, so now I have my picture. I can sort of box this in if I want, and I have that. All right, so the next piece is going into our next section, which is about sinusoids. Sinusoids are graphs of sine or cosine functions, it's basically just a fancy word, if you will, to say that we are talking specifically about sine and cosine and their transformations. And so typically instructions will say, please write the sinusoid for this function, or provide the sinusoid, or whatever it is. And that just lets you know that you need to write an equation like how we did before for sine or cosine. And so it follows the pattern of transformations that we've already talked about before. A is our amplitude, and so we can actually take a formula, and the formula would be maximum minus minimum over 2, because remember, the amplitude is the height, okay, so it's the difference between the highest and lowest, and then instead of looking at the height of everything, we're really just looking at the height from the halfway mark, which is why we divide by 2. And then our b, of course, that is our 2 pi over b, that's our period. and we won't have to work with frequency too much in this particular case. And then finally, h is our horizontal or phase shift, but because it is really difficult to find, we're not really going to focus on that. We are going to focus on the vertical, which is that k. And so this can also follow a formula where k is going to equal the maximum plus minimum over 2. All right, so please note the very minute difference between amplitude and our vertical shift. It's very important that you recognize that they're different and they give you different answers. All right, so let's do an example. So here are two examples, and we are going to write the equation for both of these trig functions. We're going to write the sinusoid. And so the first thing we need to do is we need to identify, well, what is our maximum and our minimum? And when we do this, we're going to look at our y values, not our x values, because remember, x, the domain is all real numbers, and for our range, our y values, there is a max and a minimum. So our maximum and minimum is actually 5 and -1. So to find the amplitude, I'm going to take the maximum, amplitude is going to equal 5 minus, and a -1, so I'm going to put that in parentheses, over 2. Two negatives next to each other become a positive, so it becomes 6 over 2 equals 3. And so if I want to find my midline, okay, our midline here, or if you will, if we were to cut our graph in half, then I can start at the top and I can count down 3. So here's the top. So I go 1, 2, and 3 is where my midline is. So now this line should cut it in half. And it looks like it's so, but if you want to double check, you can keep counting to the next 3. So we got 1, 2, 3. And that is our very bottom. So we know that we did cut this in half correctly. So our amplitude is 3. Then I can find my period. Remember, the period is 2 pi over b. And the easiest way to do this is to draw a line at 0 or on the y-axis and have that as your starting point. And then just follow one rotation. So if I were to follow one rotation, it would stop right there. And I'm going to, before I start my next rotation, I'm going to draw a line. And this line should hit on the x-axis at the point that I need to use. So I would write it as 2 pi over, it's supposed to be b, let me b, over b equals, and then if I were to look at this, it looks like I am halfway between 0 and pi, and the halfway mark between 0 and pi is pi over 2. Now I'm just going to cross multiply, and I'll get 4 pi over b pi. I'm going to isolate b by dividing pi on both sides. So divide by pi. These cancel out, and I'm left with b equals 4. All right, so I found my amplitude, I found my my b value, and now I need to find my k value. So again, I use my maximum and minimum, but now I'm going to add them. K is going to equal 5 plus -1 over 2, which equals 4 over 2. Now that I have all my pieces, I can go ahead and write it into an equation. Remember, it follows the format that we have above, so it should be 4 over 2 equals 2, sorry. So it should be 3, that's my amplitude. And since I start at the midline, that is following my sine function, so it would be sine 4x. And then my final piece is my vertical shift, which is 2, so plus 2, and this is my final answer. All right, example 1.2 follows the same thing. Again, you start off by finding your maximum and minimum y values. So that's 2 and -2. So amplitude is going to be 2 minus a -2. Two negatives make a positive, so that becomes 2 plus 2, which is 4, over 2. 4 over 2 is equal to 2. All right, now to find the period, we're going to draw a line at, let me put my midline first. So I got my starting point right there, and I go 1, 2, that's where my midline is, and I'm going to double check my work is correct. 1, 2, that is my minimum. Okay, so I did cut this in half correctly. And of course, you guys can eyeball it if you want. I'm just showing you the math behind it, but I frequently eyeball it and just like take a guess, and usually I'm right. So if you want to skip a couple of steps, you can. It's not a huge deal. All right, so I'm going to now start my finding my b value. So I'm going to draw my line at the on the y-axis, and I'm going to follow my function until I start to repeat myself, and I end up at this 2 pi over 3. So I'm going to write this as 2 pi over b is equal to 2 pi over 3. And so you should probably be able to look at this and automatically figure out what your answer is, but just in case you don't exactly see it, we're going to do the math. Cross multiply, you get 6 pi equals 2 pi times b. Divide 2 pi on both sides, and you should have the pi's cancel out, and 6 divided by 2 is 3. Of course, if you see that the numerator is the top in both of the fractions, then therefore you should have the same answer in the denominator as well. And so this is b equals 3. Finally, we're going to do our vertical shift, so k is going to equal to that 2 plus a negative 2 over 2, which is going to equal 0 over 2, which is 0. So this time I actually don't have a vertical shift. So when I write my equation, it's going to say 2. And I see that I do not start at the midline. I'm actually above the midline. That follows my cosine. So that would be 2 cosine of 3x. And there is no shift, so that is my final answer. All right, so let's do one more just to solidify everything. All right, example 1.2b, which is going to be this problem over onto the right-hand side. I'll let you do letter B and the left-hand one on your own, but the right-hand one we'll do together. So the first things we have to do is identify our max and minimum x values, or y values, which is going to be 1 and negative 3. So that's going to be a equals 1 minus a negative 3 over 2, which is 4 over 2, which is 2. All right, so I can start at my starting point. I can count down. So I got 1, 2, and that becomes my midline. And I can just double check. 1, 2, perfect. That is my minimum. So I did cut this in half correctly. It's a little slanted, but we will ignore that. All right, finally, I can start finding my b value. So I'm going to draw my line at 0. I'm going to follow my function until it starts repeating, and it stops right here. So I'm going to draw this line, and I see that it hits between 3 over 2 and 5 over 2. So the number between 3 and 5 is 4, so it would be 4 over 2. So I would write this as 2 pi over b is the same as 4 over 2. And I would cross multiply. 2 times 2 pi is 4 pi. 4 times b is 4b. All right, you guys should be starting to see what this is going to equal. But I can look at this, and I can divide 4 on both sides, and I can get b is equal to pi. All right, so I know that my my b value will be pi. So now I can do the final piece, which is finding my vertical shift. That's going to be 1 plus a negative 3 over 2, which gives us a negative 2 over 2, which is equal to negative 1. So now I can draw, or I can write my equation. And my equation, you have to figure out if it's sine or cosine, and we can see that our function starts at the midline, which follows a sine pattern. So the answer for this would be 2 sine pi x minus 1, and that is our answer. So hopefully that becomes a little bit easier for you guys. As you're working, go ahead and do the other problem by yourself, and then compare it to 1.1b on the left. So the last problem is just showing you that if we were to leave the world of frequency or the world of sound waves, that we can still apply sinusoids to other real-life examples. As I mentioned before, you could apply it to circles, just like how we did with our unit circle. The problem here is about jump roping. It says 2 people swing jump ropes, as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, and the lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height h in inches of a rope as a function of the time t in seconds, given that the rope is at its lowest point when t equals 0. So it gives you a lot of information right off the bat. And so I'm just going to ignore it for a second, and I'm going to go through and just find the key pieces that I need to get my answer. It's asking me to write a equation, which is what I've been doing. So just because the picture is slightly different doesn't mean anything. If you've noticed, they give you a maximum and a minimum, and that's really our starting point. So I'm going to take our maximum and our minimum, and I'm going to say my amplitude is maximum minus minimum over 2. So that would be 75 minus 3 over 2. 75 minus 3 is 72. Over 2 is 36. Okay? The next piece that it gives us is that the rope makes 2 revolutions per second. All right. This right here is what I've been saying previously. This is our period, okay? When we are drawing our unit circle, we have a period of 2 pi, okay? That's one complete rotation, or one revolution, if you will, or one rotation. So here we have a rope making 2 revolutions per second, but I don't want 2 revolutions. I only want 1. So that means if I have 1 revolution, that I would have to divide my second by 2. Right? I would have to half it. So, because I'm halving my 2 revolutions. So half of 2 revolutions is 1, which is what I want. Half of 1 second is 1/2 of a second. So I could set that up as an equation. I can say, okay, well 2 pi over b is going to equal 1 over 2. Okay, remember that 1/2, that 1 over 2 represents our time of 1 revolution, not 2 revolutions, but 1. And then from here I can cross multiply. This will give me 4 pi equals b times 1, which is just b. Okay, so I found my b value, which is great. The last thing I need to do is find my vertical shift. So I'm going to have k equals, remember it's maximum plus minimum over 2. So it would say 75 plus 3 over 2, which is the same thing as 78 over 2, which equals 39. All right, so the last thing that we have to figure out is, do we have a sine or cosine? Because, previously when we found our midline, we could see, okay, if it starts at our midline, well then we are having a sine function. But if we start above our midline, then it's a cosine function. All right, so we're going to apply the same idea in this particular case. I'm just going to draw it slightly different. And in order to do that, I have this piece of information that I underline. It says, given that the rope is at its lowest point when t equals 0. So they're just saying when you start off, the rope is on the ground. So if I were to draw a picture, all right, here's my picture. I'm going to draw a person. Here's a person who's holding the rope. Okay, so that little point right there, that's where 0 is, if you will. And it starts on the bottom, it goes up, and then it comes back down. All right, it goes up and then it comes back down. So this is showing that this is not starting at the midline, so it's not sine. But it's not above the midline either. This looks like cosine, but it's just upside down or reflected. And if it's reflected, then that means it's cosine, obviously, but it's going to be negative cosine. So now that I have all my pieces, I know that I have a negative cosine as opposed to a normal cosine. I'm just going to write everything all together. I know my amplitude is 36, but remember, amplitude is supposed to be the absolute value, so it's okay that we're going to add a negative to it because it's not really going to affect our answer later. So our final answer will say negative 36, that's our amplitude, cosine of 4 pi x, forgot the x, plus 39. All right, so let me include that x right here. There we go. 4 pi x plus 39. And then we box in our answer. This is our final answer. And again, it's just showing you that while we can write equations for sound waves, which is what it's most commonly used for, we can also use it for anything that's circular or anything that's oscillating. Remember, anything that's oscillating is that pattern or that motion that goes up and down, and just repeats. All right, so hopefully that was helpful. If you have any questions, make sure you reach out to me, and have a great day.